Next, we're going to calculate the critical value. And then we're going to look at the formula sheets. So we know that we're in the second situation. We're in the situation where we have mean with sigma unknown. So we don't know the population standard deviation, but we know what the sample standard deviation is. So this is a t-distributions. And for this situation, to calculate the critical value, we're going to use the formula equal t.inv. And it will ask you for the two variables. There are two variables that you need. The first variable that you need is the probability. The second variable that you need is the degree of freedom. And how we know which probability we're going to use is we need to look at the first table, the testing. Which testing are we dealing with? We know that we're in the one tail greater than testings. So therefore, for the probability that we're going to use in the critical value, we're going to use 1 minus alpha. We're going to substitute the 1 minus alpha as the probability into the formula equal t.inv. And we're going to do that right now. So we know that alpha is 0.1. So 1 minus alpha is 0.9. And you have your degree of freedom. Degree of freedom is n minus 1. So degree of freedom is your 25 minus 1, which is 24. So once we know that, then we can substitute that into the formula equal t.inv. So we have equal t.inv bracket 0.9 comma 24. We plug that into Excel. We're going to get 1.3178. And that's our critical value. Next, we're going to calculate the p-value. To calculate p-value, same idea. We're going to refer to the formula sheets, the two questions that we asked at the beginning. So we know we're in the second situation. We have sample standard deviation. So we're in a situation where we have the mean with sigma unknown, and we have the sample standard deviation. So for p-value, we're going to use t.dis. That's the formula that we're going to use. And then we're going to look at the first table to find out what we need to put into the t.dis. So when we look at the one tail greater than, for p-value, we see that we're going to use the test statistics. And then once we have done that, we're going to use 1 minus the probability. We're going to use the test statistics. We're going to substitute that into the formula t.dis. And then we're going to get a probability. Once we get the probability, then we're going to use 1 minus the probability. And that becomes the p-value. So we're going to do that right now. So equal t.dis. We put in the test statistics. So test statistics is your 0.55 that we calculated earlier. And then comma, degree of freedom. The degree of freedom is 24, n minus 1. So 25 minus 1 gives you the 24. And then comma, and then you're going to put the cumulative. Cumulative, you're going to put true. It's always going to be true because this is continuous distribution. So you're always going to put true there. So once we substitute these three variables into the equation, so we put equal t.dis, open bracket 0.55 comma 24 comma true. We plug that into Excel. We're going to get the probability equals to 0.70. And then we're going to take 1 minus the probability of that to get the p-value. So p-value equals to 0.2937. So what you notice here is that the test statistics and the p-value, all these variables come from the data source. It comes from the actual data that we get. And on the other side, we have the critical value and the significance level. So these are values that we set ourselves. These are the criteria that we set ourselves, the standard that we want. So again, test statistics and p-value comes from the data source. And then the critical value and the significance level come from our criteria, the criteria that we set ourselves. And once we have these four values, then we can move on to step 4, which is stating the conclusion. Again, we go back to the formula sheets, the first table. We look at the decision rule for rejecting H null. For the one tail greater than, we can reject H null. There's three ways. The first way is test statistics is greater than critical value, then we can reject H null. Second way is p-value is less than alpha, then we can also reject H null. The third way is the mu is outside the confidence interval. So those are the 3 ways that we can reject H null under the testing that we're dealing with one tail greater than. So the first way is we can compare the test statistics with the critical. We know that the test statistics is less than the critical value, so 0.55 is less than the 1.31. So therefore, we do not reject H null, we accept H null. We accept that the mean is less than or equal to 52. And we have the same conclusion for the p-value and the significance level. P-value is greater than significance level, so p-value is 0.29, and your alpha is 0.1. So p-value is greater than alpha, so therefore, again, we do not reject H null, we accept H null, and we accept that the mean is less than or equal to 52. So when we do not reject H null, we have insufficient evidence, so they're in pairs. And that is example 2.